Okay, so what I like to do is step back a little bit. It's going to feel a little bit more like 5.1. We're going to spend some time doing some simplification and some algebra, because the next round of verifying, proving identities involves some more algebra and simplification techniques. So let's go ahead and take a look at that and look at some situations that come up to hopefully help us be better at proving and verifying identities. So in this first round, what I want to do is do the indicated addition operations and then simplify as we can. For letter A, there's actually an easier way to get to the chase. I'll do that second. But what I want to do is just review the whole idea behind adding fractions in the first place. So to add fractions, what I need is a common denominator. So basically, secant, cosecant is my common denominator. So I would begin this one by actually multiplying and dividing both sides by what's missing with regard to the polynomial that's concerned. So for this one, what we basically need is a cosecant of x, and over here what we need is a secant of x. So there's our balancing act. When I finish that, what I end up having is cosecant of x times cosine all over that common denominator plus sine of x and secant of x all over that common denominator. Alright, and so now that I have a common denominator, I can perform the actual division itself. And so what we end up getting is cosecant of x cosine of x plus sine of x secant of x all over cosecant of x secant of x. Alright, and then we would continue simplifying as we move forward there. Alright, but this is again getting a little messy, and so I wanted to kind of show you a couple things here. Number one, just a reminder on how we add fractions. We need a common denominator and we multiply top and bottom by something to get it, but usually when you started something and it starts looking messier than when you started from and you can't really simplify more, that's usually a good symbol to maybe stop what you're doing and go back and rethink how you want to start this problem. Right? So let me go ahead and pull out another sheet of paper here for that. So we have cosine of x and secant of x, and we're adding sine of x all over cosecant of x. Okay, so now that we tried an algebra idea, right, why don't we just try using another trig identity? We know that secant, right, well that's 1 over cosine. And over here we know that cosecant is 1 over sine. So perhaps starting that way will actually get us a little bit closer to something as opposed to what we did before. Here we're going to multiply by the reciprocal, so we get cosine of x times cosine of x over 1, plus same thing here, we're going to multiply by the reciprocal, and of course we end up with cosine squared x plus sine squared x, and that we know to be 1. So take a look at the difference between these two different approaches. And again, I kind of wanted to, I'm trying to do a lot of things here at once. But number one, this obviously was a better idea to change things to sines and cosines, because even though it got a little crazy right here, I was able to push the ball forward, if you would, and advance the ball, as opposed to over here after I added fractions by finding the common denominator. Nothing was wrong with my algebra at this point, but it was kind of hard to simplify this more. Of course, if you want to think of simplifying, we're going to end up right back where we were at. So it seemed like we were going around in circles, and that's going to happen a lot when you guys are, especially when you're new to this. You're going to feel like you've just went on the wrong pattern, and that is don't fear about stopping and going back and saying, could I have tried something different? And so that was one of my main goals for that one, to review how to add fractions. We're going to need it a little bit later, and then also how to, hey, let's stop and let's reconsider what we're doing here. And that actually was very helpful in that case. All right, and sometimes that's not always the case. It just takes practice. So in the next one, how about we just change gears here? We're taking a sum and we're squaring it. So again, that means we're taking tangent and cotangent and we are multiplying it to itself. Okay, and when we FOIL this, we get a tangent squared. It looks like we get a tangent of x, cotangent of x, another tangent of x, cotangent of x, and then plus cotangent squared x. Alright, and so if we put things together here, this part right there, right, we have tangent of squared x plus 1, because tangent and cotangent are basically reciprocals of each other. We have another plus 1 cotangent of x squared. Okay? And then at this stage, we know that tangent squared plus 1 is actually secant squared plus, and this is actually cosecant squared of x. Okay? So there would probably be, we could probably push that further if you want, but we definitely performed the operation, right, squaring that sum, did the FOIL, used a reciprocal identity to come up with a couple of ones, and then rather than adding the ones, I kept them apart because I saw a Pythagorean identity there, and I saw a Pythagorean identity right there. So at this stage, we know that this is secant x plus cosecant squared x. Right? And could we go further? Could we do something else with it? Maybe, maybe not, but that's as far as I want to take that. Alright, and then last but not least, what we have here is we're subtracting and my denominators are different. So the way we go forward is we multiply both in top and bottom by what's basically missing. And so I would actually have to multiply the top and bottom of this one by sine x plus 1. I think I wrote it down a little wrong. Right? And then on the other side, we need a sine x minus 1. And that'll get the trick done. So we already had the plus 1. I need the sine x minus 1. Alright, so there's the first move in terms of subtracting fractions. What I have downstairs in both these cases is I've got sine squared x minus 1. Right, on the bottom there. And on the top, we have sine x plus 1. If we distribute that minus, I have a negative sine x plus 1. Alright, and so the sine x's will actually cancel out. We have 2 over sine squared x minus 1. Alright, and again, we still have a quotient to deal with. So, you know, what could I do next? Well, if we look at this, this is basically your cosecant squared, but in reverse. Right? So perhaps let me do some scratch work up here. We know that cosine squared x plus sine squared x is equal to 1. But if I basically subtracted cosine squared x on both sides and subtracted 1 from both sides, right, we get sine squared x minus 1 equals negative cosine squared x. So what we have here then is 2 over negative cosine squared x. Of course, that is negative 2 times secant squared x. So reviewing how to add fractions or subtract them, find a common denominator, multiply top and bottom by that item. We got lucky. The bottom happens to be the difference of squares, which eventually turned into our Pythagorean theorem. The top, we have to distribute the minus. We got lucky, some things canceled out, and then we were just basically one last reciprocal identity away from simplifying that. Is there other ways to simplify this? Sure. All right. Is there another result of this? Maybe. All right. But for the work I'm showing, there would be my simplified form of that subtraction of fractions. Okay, and then this pretty much just goes on and on. So again, performing operations and simplifying as much as we can. Part 3, I kind of have a different outlay, but it's pretty much the same thing. We're going to perform the operation and then simplify as much as possible, and what we're hoping to get is a constant, a singular function, or a power of a singular function. And you kind of see that was happen up here. Upstairs here, we ended up getting that this was equal to 1, right? So we got a constant. Up here, we got a power of 2 functions, and down here, we basically got a power of a single function. So we can kind of see that playing a role up on top on part 2. Part 3, we're just going to continue that. But I'm 10 minutes in, so why don't I start fresh with a new video coming soon.